Hey guys, in this video we're going to look at a absolute value inequality, and this is a real world problem. So this would be like modeling with absolute value inequalities, and this is a typical EOC style question, and this is what you guys are going to have to be facing when you take that EOC, and it may not be easy. So let's take a look and see what we got here. This one says, at a certain factory that produces washers can have a width of 1.5 plus or minus 0.2 centimeters. Let W represent the width of a washer. A diagram of a washer is shown below. And so a washer is just a ring that you generally put when you put a bolt and a nut together, and you put the washer in between to protect whatever material it is that the bolt is holding together. And so this washer right there has a width of W, and it's just a ring. It says write all possible widths as a compound inequality. So as a compound inequality, what we look at up here is 1.5 plus or minus 0.2. So the smallest value that can have, and still be okay, is going to be 1.5 minus 0.2, which should be 1.3. So 1.5 minus 0.2 is 1.3. So that's the smallest one. The largest one it can have, the largest diameter is 1.5. It says, I'm sorry, width, not diameter, width. 1.5 plus 0.2 is 1.7. And so it's going to go from 1.3 to 1.7, and anything in between is okay. And so then what you do is you put less than or equal to, less than or equal to, and the variable is W for width. And there's your compound inequality. So now it says to write all possible widths as an absolute value inequality. This is where it gets a little bit tougher. And you kind of have to think backwards here. You have to think, what absolute value inequality would have this as an answer? Well, first of all, we know it has to be an and, because an and compound absolute value inequality is the answer is going to look like this, where it's like the inside of the graph. And so if we think about it, we need to set that up so that we get these two values as our answers. And so how can we do that? Well, we have the 0.2 as the thing that is, it's got to be less than or equal to that. So it goes from 1.3 to 1.7. So if you just start putting numbers and stuff in here from down here, you can quickly realize if your answer is going to give you this or not, right? So I'm going to put something down here, and I'm going to see if it's going to give me this answer when I solve it or not. So let's say I do W, and let's say I do minus, and this one I'll put 1.5, less than or equal to, and then I'll put 0.2 down for this one. Let's just say I guessed those 5 things, and now I'm going to sit there and try and figure out if that's actually the correct answer. Well, if I solve this, that should be my solution set. So let's solve this and see if it's our solution set. If it is, then we're good, and if it's not, then we're going to have to make adjustments. So the first one would be W minus 1.5 is less than or equal to 0.2. So if we solve that, add 1.5, and you get W less than or equal to 1.7, which is really good because that's this part, isn't it? So we got that part. Now we just need this part. Okay, so our second one is going to be W minus 1.5, and we flip the symbol and we make that negative. So now, let's see, add 1.5, and so we get W greater than or equal to 1.3, and that, if you turn it around the other way, just twist the whole thing around, you would get 1.3 less than or equal to W, which is exactly the same as the left part of this. So this is the same thing as this is the same thing as this, and since it's an and, because the symbols point to the left, you can put them together and make that inequality right there. So now we figured out that this, I guess you would say a guess. It wasn't a guess because I kind of already knew what to be looking for, but it did work. And if it was wrong, then we would just go ahead and make some corrections, such as if you put a plus right there, that would have messed everything up, because if you put a plus right there, then you would have been subtracting 1.5 on both sides, and you would have gotten some negative numbers probably here. That wouldn't have worked. If you switch these two numbers, then you wouldn't, and you tried to solve it, you wouldn't have gotten these two back. You would have gotten something else. Or it could have been negative or something like that. So this is a really good EOC question, and I just wanted to show you what to do if you're faced with something like this, that you can logically figure out what the answer is by kind of just working with what you're given here and seeing if you can get your compound inequality, your absolute value inequality, to look like what it's supposed to look like. Because this part's not really that hard. That just comes from this. That's easy. This is the one that a lot of people mess up on. So this has been absolute value inequalities and some modeling. And so remember to like my video and subscribe to my channel if you haven't already. And we'll see you guys later. Bye.